an example here. Let's determine whether the series n equals 1 to infinity, 2n squared plus 3n over the square root of 5 plus n to the 5th converges or diverges. This series again has positive terms. The numerator's positive, the denominator's positive. So that means I have an option of using a comparison test here. So if I wanted to use the comparison test, right, I said we make small changes to get, but if you look at this, it's really too complicated, right? The numerator has a lot going on, has two terms, and the denominator has a lot that's going on. So for this one, I wouldn't use the direct comparison test. Instead, I'm going to go with the limit comparison test. Okay, because it's too much. If I make too many changes, it's going to be hard for me to figure out which one is bigger than the other. Okay? So, what am I going to compare this one to? Well, the way you figure it out for these is you take, essentially I almost have a polynomial over a polynomial except for the square root, but that's okay. So what you do is you identify your largest degree term in the numerator. So what's my largest degree term in my numerator? 2n squared. Okay, so you separate that off, 2n squared. And then the denominator has a square root. But let's look at our largest term here. What's inside the square root? What's my largest degree? Into the 5th. But it's underneath a square root, so I'm going to take n to the 5/2. But I can simplify that expression a little bit so it's a little bit nicer. This is really the same thing as 2 over n to the 1/2. So you take 5/2 and subtract 2. Does this series have positive terms? Yes. So great. Both have positive terms. And I'm going to jump immediately, because I'm doing the limit comparison test, to computing the limit after this. I don't have to compare.
That's a P series.
Mm-hmm.
It's less than
Yeah.
that's divergent.
Exactly. So maybe I'll go ahead and write that down since you told me it. I don't want to forget. This is a P series. We said P is 1/2. P is less than 1. So this diverges. Okay. And you should be able, whatever you're comparing it to, you should be able to do that. You immediately told me if it converged or diverged, right? You should be able to do that. That's the whole point. My thing is too complicated, so I'm reducing it down to something that's easier, kind of, okay? Compute the limit of an over bn. So an was the terms in my series, so it was 2n squared plus 3n over the square root of 5 plus n to the 5th. And I'm going to divide that by 2 over n to the 1/2. So I'm going to flip my denominator up. 2n squared plus 3n n to the 1/2 over 2. So now what I need to do is I'm going to distribute that n to the 1/2 to both terms here in my numerator. So I'm getting 2n to the 5 halves plus 3n to the 3 halves over 2 square root 5 plus n to the 5th. Okay, so from here I need to compute this limit. You could use L'Hopital's rule if you want, but it's gonna be messy because of the square root in the denominator. So I wouldn't do this as L'Hopital's rule. Instead, what I'm gonna do is I'm gonna multiply top and bottom by 1 over n to the 5 halves. And distribute in the numerator. Okay, so we're gonna get the limit as n goes to infinity. It'll be 2 plus 3 over n. 2 times this, and then I'm gonna pull this n to the 5 halves. That's really, maybe I'll erase it here and put it as, it's the square root of n to the 5th. It's the square root of n to the 5th. So I'm going to combine these two square roots together, which means I need to distribute this. So you're going to get 5 over n to the 5th plus 1. And now we're ready to evaluate the limit. The limit of 3 over n, that's 0. So you're getting 2 plus 0 over 2, the square root, 5 over n to the 5th, 0 plus 1, exactly. So I'm getting 2 over 2, which is 1. And again, all I care about is that I get a finite number that's bigger than 0. So now these two series have to behave in the same way. They either both converge or both diverge, but you told me that one of them diverge. So what's my conclusion for this, for the series I was asked about?
It diverges.
It diverges, So the series I was given, which was 2n squared plus 3n over the square root of 5 plus n to the 5th, diverges by LCT, limit comparison test. Yes.
So why couldn't you say they diverge by ECT earlier?
So the issue is, if we go back, I have my two series, and you need to have an inequality between them. You need to know which one of these is larger. But remember, I made a lot of changes to create this new one. I changed both the numerator and denominator. And when you change both numerator and denominator, it makes it hard to compare these. Like in the first example, I only changed like one of them. I only changed the numerator, or I only changed the denominator to make up my new one. But this one I had to make two changes. I had to change the numerator and change the denominator. And that's a lot of change in order to say which one is bigger. It's going to make it difficult. So a lot of times if I make too many changes, I'll just go for the limit comparison, because then I don't have to figure out which one is bigger than the other. Yeah.
Can you walk me through how you got A sub n to B sub n?
Okay, so what I did, is if you forget about the square root for a minute, it's almost like I have a polynomial over a polynomial, right? So what I do is I identify my largest degree term in the numerator. So what's my largest degree in the numerator? 2n squared. So that's the term I'm going to keep. And then I look at the denominator. Inside of the square root, what's my biggest term? My largest degree. N to the 5th, but it's underneath the square root, which means I have its n to the 5 halves. that's how I created my new, the one I'm gonna compare it with. Yeah.
Why did you only distribute the 1 over square root of 5?
I distributed it to, hold on, down here, right?
Yeah.
Yeah, you distribute it to the first one. So the first one, that's how I'm getting the 5 over n to the 5th. But over here, I'm getting n to the 5th over n to the 5th, which is 1.
Why did you leave it 2 out? You don't distribute to them?
No, the 2 is just your coefficient, so you don't have to distribute it to the 2. Yeah, yes.
So if, so basically just want to clear this up. If I find that if a divergence converges, and then on the limit test, it's greater than 0, then it means it's either converge or diverge.
Yeah, it agrees with whatever you got before. Exactly. You need to make sure it's a finite number, though. It's not infinity. Yeah.
Can I see the bottom of it?
Yes.